In 1972, we said goodbye to the moon convinced we had conquered the impossible. We celebrated the Apollo missions as the pinnacle of human achievement. Flags were planted, parades were held. The world watched in awe. But here's the uncomfortable truth that nobody likes to say out loud. The Apollo astronauts weren't exactly in control. They were surviving through an improvised technological miracle, held together by slide rules, paper charts, and raw nerves. It was brilliant, it was heroic, and it was never the full picture. That was 1972. In 2026, the game has changed completely. In just a few months, Artemis II won't simply repeat history, it's going to humiliate it. 4 human beings are about to enter a region of deep space that NASA itself officially classified as intransitable for over 50 years. And what they're going to find out there isn't just a new distance record. It's something the Apollo crews were strategically forced to ignore just so they could make it back alive. What we deliberately looked away from for half a century is exactly what Artemis is flying straight toward. What Apollo was blind to. When you think of the moon, you think of gray, a desolate, colorless rock floating in the void. And there's a very specific reason for that. Apollo's sensors were essentially blind to the true spectrum of the lunar environment. They saw what they needed to see to land a module safely. Nothing more. The picture was intentionally incomplete because a complete picture would have been too dangerous to acknowledge. Artemis II arrives equipped with a full suite of multispectral sensors that see deep into the infrared and ultraviolet. For the first time in history, we aren't just looking at the moon, we are diagnosing it, layer by layer, frequency by frequency. But it's not only the colors that are changing. During the Apollo era, Mission Control routinely dismissed strange thermal spikes on the far side of the moon as instrument noise or sensor glitches. They had to. If they admitted the environment was that volatile, the missions would have been scrubbed immediately. No landing, no giant leap, just silence. Artemis is flying straight into the heart of those anomalies. We've discovered a thermal signature in the lunar crust that simply shouldn't exist, a heat variance that separates a basic landing spot from a genuine long-term colonization zone. If Apollo was a blind leap into a dark room, Artemis is turning on the floodlights. And what we're seeing in those shadows is precisely the reason we stayed away for 5 decades. To understand the true gap between these two missions, you need to sit with this fact for a moment. The computer that took Neil Armstrong to the moon had less processing power than the chip inside a modern toaster. In practice, the astronauts themselves were the CPU of the spacecraft. Their brains were the backup system, the primary system, and the emergency system all at once. The Orion capsule, the heart of the Artemis II mission, is something else entirely. It's controlled by an advanced artificial intelligence architecture that makes billions of decisions every single millisecond. It calculates orbital corrections in real time that previously took entire teams of mathematicians in Houston hours to verify and approve. But this superbrain creates a terrifying new danger: digital silence. In the Apollo days, loss of signal lasted about 30 minutes as the spacecraft passed behind the moon. It was a break in the radio, tense but manageable. Mission Control would wait. The crew would wait. Then the signal would return, and life went on. But Artemis is going much further than the moon's shadow. It's entering a zone of deep signal lag. Because of advanced encryption protocols and the sheer distance involved, there is a point in this mission where the AI and the crew will be truly, fundamentally alone. no backup, no relay. In that absolute void, the psychology of the crew is tested by a silence the human mind has never encountered before. NASA classifies this mission as category isolated for a very precise reason, and what the crew is trained to hear during that silence is the primary reason this mission represents a one-way journey into a completely new reality for humanity. How Artemis uses the human body as a radar. There's a popular conspiracy theory claiming humans never passed through the Van Allen belts because the radiation would have killed them instantly. It's false, but it's built on a grain of real truth. Apollo did go through. It just did it the only way it safely could, at maximum speed, like a hand passing quickly through a candle flame. Fast enough that the damage stayed manageable, fast enough to survive. Artemis VI isn't punching through, it's lingering. Orion is literally a tank compared to the Apollo command module. It's constructed with hydrogen-rich shielding, specifically engineered to deflect galactic cosmic rays. Particles moving so fast they can tear through DNA like a bullet through wet paper. The physics are brutal. The engineering required to counter them is extraordinary. But even with the most advanced shielding ever built, there is a side effect that NASA rarely discusses in public. Deep space radiation does something very specific to the human eye. Astronauts report seeing flashes of blue and white light, even with their eyes completely closed. These are heavy ions, literally striking the retina directly. In 1970, this was logged as an uncomfortable curiosity and mostly ignored. In 2026, the Artemis crew is actively using these phosphines as a biological sensor. By mapping precisely where and when these flashes appear, they are feeling a magnetic structure in deep space that Apollo was never equipped to detect. We are using the human body itself as a radar for the invisible architecture of the cosmos. The dead zone and the most dangerous return in history. This is the moment where Artemis leaves the ghost of Apollo behind for good. At its furthest point, the crew will be over 400 EUZ kilometers from Earth. At that distance, our home planet isn't the big blue marble from the famous Apollo photographs. It is a pale, tiny dot that you can cover completely with your thumb. The psychological weight of that image, of covering the entire world with a single finger, is something no Apollo crew ever experienced. Artemis will. This is what Apollo was forced to ignore, the true nature of the void. The Apollo missions were tethered to the moon's gravity. They stayed close to the perceived safety of lunar orbit, never venturing beyond a certain threshold. Artemis II is intentionally breaking that tether. It's entering the dead zone, a region where the gravitational grip of both the Earth and the Moon begins to lose its hold, where the spacecraft drifts in a gravitational no-man's land between worlds. This isn't just a distance record. It's a genuine stress test for the eventual leap to Mars. But the real terror happens on the way home. Apollo returned to Earth at 39,000 kilometers per hour. It was a violent, flaming, brutal re-entry that pushed every material to its limit. It will test a skip re-entry, literally bouncing off the upper atmosphere like a stone skipping across the surface of a lake, bleeding off heat in stages before the final plunge. If the angle is off by a fraction of a single degree, the crew doesn't land. They either incinerate instantly or skip off into the void forever. Apollo's heat shields would have disintegrated under these pressures. It wasn't a question of endurance. It was pure physics. Every capability that outclasses Apollo, the visual sensors, the artificial intelligence, the radiation mapping, the psychological isolation protocols, is preparation for the Project Cosmos endgame. We aren't going back to the moon to collect rocks and leave footprints. We are going back to stay permanently. If the Artemis II crew survives the deep silence and the dead zone, they will have opened the door to the most dangerous mission in human history, Artemis III. Because while Artemis II breaks records in the light, Artemis III is heading for the South Pole, into craters of eternal darkness, places where sunlight hasn't touched the ground in 2 billion years. 2 billion. That isn't rhetorical exaggeration for dramatic effect. That is geology. NASA's satellites have already detected something inside those craters, something that doesn't fit the geological profile of ice or rock, something that doesn't match any model we have. The Artemis II mission is the only path to verifying whether the signals we're receiving from the pole are entirely natural in origin, or whether we are about to discover that we planned this lunar base without knowing something crucial about who or what was already there. The cosmos is not empty. It never was. And the deeper we push, the harder the unknown pushes back. The crews of Apollo accepted the limitations of their time with extraordinary grace and courage. They went knowing the instruments were incomplete, knowing the data had gaps, knowing that certain readings were being quietly set aside so the mission could continue. That took a different kind of bravery than what we celebrate today. Not the bravery of knowing exactly what you're facing, the bravery of going anyway, with full knowledge that you didn't know enough. Artemis II is built on 50 years of accumulating exactly what Apollo didn't have. Every sensor, every algorithm, every line of shielding exists because someone, somewhere, looked at the gaps Apollo left behind and decided we had to fill them before we went back. That slow and painful process took longer than anyone wanted, but the mission it produced is truly unlike anything the entire history of space exploration has ever seen before. Subscribe to the channel and turn on all notifications so you don't miss any new updates. See you in the next video.